a good habit to get into when you're looking at converting IP addresses into decimal format is to, first of all, before you do anything else, make yourself a little template. So you know you're going to have 8 bits to work with. Write out the weight values for each of those potential bits. Very easy for binary because each position as you go to the left doubles. You always start at 1. The first position right here, this first position with anything is always going to be 1. And for binary, the values double as you move to the left. So that gives you the weight values for each binary bit position. Now when you go to convert something, write whatever you're converting in the blanks and just use that as a guide to do your conversion. It's a really good idea to do this when you're first starting out because it does take a little bit of getting used to it first. Once you've done quite a few of them, you kind of get the hang of it, and you don't need this so much anymore. But to start with, we're going to use this. So we'll do another example of something, and this time we'll do an 8-bit number instead of a 4-bit number. Say 10010011. So we'll convert that. So again, we do exactly what we did before. Multiply each digit by its weight value and add them up. So we get 1 times 128, 0 times 64, 0 times 32, 1 times 16, 0 times 8, 0 times 4, 1 times 2, and 1 times 1. If we add all of these up, what we'll end up getting is 147. So 10010011 in binary is 147 in decimal. And this is a common thing that we have to do when we're working with IP addresses. Later on we'll see exactly why we have to do this, but these are common operations that we have to be able to do some of the more advanced things. So that's our first type of conversion. Now we can do, before we move on, we'll do one more long example, and then we can look at converting the other way, converting from decimal numbers to binary numbers. So I'm going to leave my blanks here because I want to use that. And we'll pick another number, say 10101100. Again, same thing, multiply the digit by the position value. So 1 times 128 plus 0 times 64 plus 1 times 32 plus 0 times 16 plus 1 times 8 plus 1 times 4 plus 0 times 2 plus 0 times 1. So now we can go ahead and add this up, and what we get is 172. 128 plus 32 plus 8 plus 4. Add the whole thing up, and that gives us our final decimal value. So 10101100 in binary equals 172 in decimal. So that's how we do the conversions going from binary numbers to decimal numbers. Now there's various ways that we can go the other way, but there's one way that tends to be the easiest. It can be a little bit of work with very long numbers, but when you're working with numbers that are used for IP addresses, i.e. in the range of 0 to 255, it's actually not too bad. And so we'll look at a few of these, and the method we're going to look at is repeated division. And what we basically do, and again, this will work in the same way that that last system that we looked at will work for converting any number system into decimal. This will work for converting decimal into any other number system. And what we're going to do is we're going to take our decimal number, whatever it happens to be that we're converting, and we're going to repeatedly divide it by the base of the number system that we're trying to convert to. So if, for example, I want to convert decimal 10 into binary, what I'm going to do is repeatedly divide it by 2. That's the base that I want to convert it into. So 10 in base 10, converting it to base 2 or binary. I'll repeatedly divide this by this base, and that will give me the binary version of that number. And again, that will work for any other number system. If I changed the 2 to an 8, for example, that will convert that number into octal. If I change it to 16, it'll convert the number into hexadecimal. So we'll look at how we go about doing this, and it involves repeatedly dividing, recording the remainder when we do the division. So we never work with decimals in here, only remainders, and we'll see how that gives us our converted value. So we start with 10, and we start off by dividing by 2. 10 divided by 2 equals 5, remainder 0. Then what we do is we keep repeating this. But what we do in the next step is, instead of taking this, we take this now. And we divide that by 2. Five divided by 2 is 2, remainder 1. Again, as we said, we're not going to use decimals. So we don't want to say 2.5, we want to say 2, remainder 1. There we go. Again, we'll take this, bring that down, and that's what we'll then divide by 2. And we do it again. 2 divided by 2 equals 1, remainder 0. And we repeat again. Same thing, take the 1, whatever's here, bring it to here, and repeat again. One divided by 2 equals 0, remainder 1. Now this is where we stop. The reason we know that this is where we stop is because we now have a 0 here. We have nothing left to bring down. This right here that tells us we're done. As soon as we see a 0 in this position, as long as we have any other value, we'll keep bringing it down here and dividing. And we'll continue that until we get this value here.